Hello everyone and welcome back. This is Bijan Ushia. In this lesson, we are going to discuss numbering systems such as binary numbering system, decimal and hexadecimal numbering systems, and how to convert one to the other. The reason is that we need this knowledge when we are dealing with IPv4 and IPv6. Hope you enjoy it. Thank you very much.
There are binary numbering system, decimal numbering system, and hexadecimal numbering system. Binary numbering system is a base 2 numbering system. There are 2 bits in binary numbering system. They are 0 and 1. The smallest unit of information is called a bit. It could be either a 0 or a 1. A byte is grouping of 8 bits together. Decimal numbering system is base 10 numbering system. There are 10 digits, 0 through 9. Hexadecimal numbering system is base 16 numbering system. There are 16 digits. They are 0 through 9 and A through F. In order to distinguish a hexadecimal number from a decimal number, we put either OX in front of hexadecimal number or a lowercase h after the hexadecimal number to indicate that the number that we are seeing is a hexadecimal number. Obviously, if that number includes digits 0 through 9 and A through F, then it is easy to distinguish it as a hexadecimal number. IPv4 address is a 32-bit binary number, but we are using it in decimal dotted format. It is easier for us that way. For that reason, it is important to learn how to convert binary to decimal and decimal to binary. This chart is used to convert an 8-bit binary number to its decimal equivalent and also to convert any decimal number within the range of 0 through 255 to its 8-bit binary equivalent. The chart shows 8 bits, bit 0 through bit 7. The least significant bit is bit 0, the most significant bit is bit 7. The decimal weight of each bit is written underneath. Bit 0 has decimal weight of 1, bit 1 has decimal weight of 2, bit 2 has decimal weight of 4. In order to come up with those numbers, you have to take 2 because we are dealing with base 2 numbering system and raise it to the number of that bit. For example, for bit 0, 2 raised to the power of 0 is 1. For bit 1, 2 raised to the power of 1 is 2. 2 raised to the power of 2 is 4 for bit 2. And 2 raised to the power of 7 is 128 for bit 7. Now that we learned how to create that chart, we are going to use it to convert an 8-bit binary number to its decimal equivalent. We are going to write the binary number in the second row and multiply each bit by its position value. We write 11000000 in the second row. Then we are going to multiply 1 by 128, then 1 by 64, then 0 by 32, then 0 by 16, then 0 by 8, then 0 by 4, then 0 by 2, then 0 by 1. And then we are going to add up the result of all those 8 multiplication that we just did to come up with the result, which is 192. 192 is the decimal equivalent of the binary 11000000. IPv6 addresses are 128 binary bits. They are represented in 32-digit hexadecimal numbers. For that purpose, we need to learn how to convert decimal and binary to hexadecimal. The table shown in here has 3 columns. This table is being used to convert binary and decimal to hexadecimal and vice versa. The three columns are named decimal, binary, and hexadecimal. Under decimal, there are 16 numbers written, 0 through 15. Under hexadecimal, the 16 digits of hexadecimal are written orderly, 0 through 9, A through F. And then the 4-bit binary equivalent of those numbers are written under binary column. The 4-bit binary equivalent can be obtained from the chart that we use to convert an 8-bit binary number by using the lower 4 bits of that chart. Let us do an example of converting an 8-bit binary number to hexadecimal. The 8-bit binary number that we have is 11000010. The first thing that we will do is we are going to group that 8-bit binary number into two 4-bit groups. Those groups will be 1100 and 0010. Then we are going to look up the hexadecimal equivalent of each group from the table that you see on the screen. In the table, we can find out that 1100 in binary is equivalent of C in hexadecimal, and 0010 in binary is equivalent of 2 in hexadecimal. When we put them together, then binary number 11000010 will be C2 in hexadecimal.